For this question, we've got the system of three equations, and what we're looking for is the value of A that's going to give us non-trivial solutions. So you might be able to figure out one or two of the values here by kind of just noticing the repetitions in the equation. But to make sure you have all of them, what we should do is, as always, use a matrix. So because I've got all the zeros on the right, I am not going to use an augmented matrix. I'm just going to use the coefficients. So for the x's, I've got A11, the y's are all 1, and the z's are 1, -1, and A. And I don't really need the 0 column to keep track of that. And yeah, so I'll just do the usual and yeah, start using one of the ones to eliminate everything else. So I'm going to use this one here and use it to get rid of the A above it. So I'm going to do the second A of the second row from the first to get that into a 0. And so that's going to be 1 minus A, and then that should be 1 plus A. It's 1 minus -1 times A. I'm not going to do anything to the second row, and then I'm going to subtract the second row from the third to get, that should be A plus 1. And if I want to keep going, I could start really mashing around with the A's, but I think from here we should be able to make some conclusions. Basically, I may or may not have pivots here, here, and here. And maybe if you want to see it better, I could flip some of the rows around. I could just flip rows 1 and 2 to get 1, 1, -1, 0, 1 minus A, and 1 plus A. And 0, 0, and 1 plus A as well. So basically, the only way that I have non-trivial solutions is if at least one of these things is not a pivot. So yeah, basically, as long as either of these two are 0, it means that I will have a free variable. So if the third one, if 1 plus A is equal to 0, then basically that means A is -1. And so what my matrix looks like in that case is basically I have that 0 row, which means I have at most 2 pivots. So I know that I'm good to go there. And my equation is going to be 1, 1, -1, 0, 2. And this will be a 0 when I plug that in, and then 0, 0, 0. And so pretty much I will have a free variable here. And so I will let z equal t. And the second equation tells me that 2y equals 0, so y is 0. And the first equation says that x plus 0, because that's y, and then minus z is t, is 0, so x is t. And so my solution is x is t, y is 0, and z is t. So now if I look at the other leading entry, if I take the other one and say 1 minus A is 0, so what I'd have in that case, if that's a 0, then regardless of, even though these two things look the same or look different, regardless of, if they're the same or different, I would not be able to have a pivot in the second column. These things may or may not cancel each other to some capacity, but I would never be able to get a leading entry in that second row or second column just because that thing is a 0. So it means I'm going to have a free variable somehow. And so this is also going to give me non-trivial solutions. So if A is 1, and I can see that as soon as I plug it in, I can see that I'll have 1, 1, and -1. I'll have 0, and this is 0. And then this will be 2, and then the other one will be 2. And since one of them is just a multiple of the other, I can wipe it out and have my free variable here, which I'll say is y equals t. And the bottom equation says 2z equals 0, so z is 0. And I know y is t, and then I have, so x plus t minus 0 is 0, so x is -t. And so this solution is -t, t, and 0. And so the only way that we get non-trivial solutions is if A is plus or minus 1.